So why was he wrong? Why was Malthus, Ehrlich, or even Thanos wrong? Now, let's be clear. When I say that he's wrong, I am critiquing their original hypothesis and just their original hypothesis. Right? And remember, all of them, right, their original hypothesis was that if population were not kept in check, then disease and famine will happen and will check population for us. Right? There will be this natural check. Okay, none of them addressed, especially the Malthusian hypothesis, did not address the environmental degradation. Right? None of them talked about or framed the hypothesis as saving the planet. It was only about saving people. Okay, and so based on that, based on that specific hypothesis, right, and looking at the data, I think it is pretty safe, at least up to this point, safe to say that they are wrong. Okay, so let's see why. Right, let's talk a little bit about why are they wrong. Right? So most of it has to do with technological improvement, right, that allow us to overcome this limit to growth. Right? Capital investment, right, increased productivity. We have mechanicalized the agriculture industry. Okay? How so? Resources can be substituted. Right? And so I want you to think about the circular flow diagram that we talked about in previous class. This idea that market will drive information, and as resources become more scarce, right, as it becomes more costly, then innovation through technological innovation, right, and resource substitute will allow the growth to continue. Right? Human labor is replaced mostly with fossil fuel. Right? Limited land, well, we increase fertilizer usage. Okay? We can do more with less. This is on the other variable, but increased wealth, right? Decreased population growth. This is especially true in developed countries. Okay. We'll touch on these points in more details a little bit later. On the agriculture side, we're going to dedicate a whole chapter 16, to agriculture. So definitely talk more about that. All right. And here is one of my personal observation. The hypothesis by Ehrlich, right, view people as the source of the problem, right? Remember that first chapter and the first paragraph in the first chapter, right, from his book. Right? He went to Delhi, India, and he sees the conditions, and those are bad conditions. No one can deny that, right? But he related that to the people, or people as the problem. All right. Now, so just by comparison, I looked this up in 1960. In 1966, the Delhi population was 2.8 million. Paris population is about 2.5 million. All right, pretty close. Okay, what were the condition in Paris like? I just Googled some random pictures, but you can see, right? It doesn't look like there was the condition there looked just fine, right? So then, he could have easily made this comparison, right, with a thriving modern city like Paris, and at least question his conclusion that people are the problem, that it's a battle between people versus resources, right? Because what if it's not people versus resource? What if people are a resource? What if the reason that Paris and other Berlin, right, New York, and other these developed cities, what if the reason why the living standards could increase is because of people? Now, I mentioned earlier that Malthus was proven wrong because of technological improvement, because of the increase in productivity. Right? But don't take my word for it. Right? Let's see if we can build a model where we can not only to justify, right, our hypothesis, right, but furthermore, let's see if we can learn anything from the model, the relationship between population and population growth rate and productivity of people. Okay. All right. Now, before we start, let's do a quick math primer here. All right. So I just want to catch everybody up on what's the difference between linear and exponential. We've been talking about it at the beginning of this class. Okay, but I just want to make sure people sees, or sorry, what everybody knows, what we're agrees what we're talking about here. Okay? So here, let's say linear. Okay, so an example of a linear trend would be, all right, 2, 4, 6, 8, and 2, 4, 6, 8, 10, and so on. Right. So this is the idea. This is an example of a linear trend. Right? Now, what about exponential? Okay, 2, 4, right? 8, 16, 32. Okay, where's the difference? So here, linear, we say there's a common difference. Okay? With any kind of linear equation, right, from one number to the next, right, the difference is the same. Okay, with exponential growth, we say that it is a common ratio. Right? It is being multiplied, right, by a consistent number every time. All right, and graphically, right, we can see just a quick sketch here. Right, graphically, a linear function, right, will be like something like this: 1, 2. This will be, right, 2, and this would be 4, and so on. With exponential, right, we can start at 1 is 2, 2 is 4, right? But then it quickly grows up. So at 3, whereas 3, right, you could have 6, but then at 3, the third number will be 8, and so on. So exponential growth, you have the slope changes, right, as you go. Okay, all right. All right. Now, a couple of terminologies, definitions, from microeconomics and macro that we'll be using. Okay, very simple stuff. GDP, gross domestic product. Okay, total market value of all final goods and services produced within a nation's border in a year. Okay, we're going to use GDP, right, as a proxy for living standards. Okay, a proxy is not the variable that we're interested in, but it is related and it represents the variable that we're interested in. So the real variable that we're interested in, and the most national leaders, right, and what everybody should be interested in, is living standards. Right? GDP is one of the best measure of living standards. It is not a perfect measure. It is not the only measure, but it is one of the best ones. Okay, all right. Per capita GDP, right? This is I would say a slightly better measure because it actually takes population into account, right? So, for example, right, China has a very high GDP, but it doesn't have a very high GDP per capita, right? China is the second largest market in the world, likely to overtake the U.S. at the rate the U.S. is going, right? But per capita GDP, right, it is still ranked pretty low, right, internationally. Okay. So per capita GDP, right, tells you better, right? It's a better measurement, right? It's a better measurement to to GDP if we care about the living standard of individuals. Okay. We will mostly be talking about nominal GDP. So this is just measuring current prices. Think of the nominal GDP as the menu, right? As you go out and you see what's on the menu, that is the real price. That is the nominal GDP. Real GDP, right, is adjusted for inflation. Right? Think purchasing power. Like how much does your money really buy? Right? That's the real GDP. It's a little misleading because for people who are not used to these definitions, right, you tend to think real as what you see, and nominal as what's the other way around, basically. Nominal as what's behind the background. But nominal is what you see. Real is what's real. Right? Okay. Now, so we're going to build a model. Right? We're going to build a model, and the goal of the model is one, right? Can we build a model looking at GDP, right? That looks at productivity. Right? Because remember, that was the argument. Right? That was the argument that the reason why we can overcome this limit to growth is because productivity increase. Okay, so can we build a model that relates productivity to GDP? Okay, and second, is this model useful? Right? Does this model tells us anything about the growth rate, right, of productivity and GDP? Okay. Now, here's a model of the GDP that you might have seen in macroeconomics. Well, okay, I should say you definitely have seen it if you take in macroeconomics. Okay, but that's okay. Right? For those of you, it's not a prerequisite. And those of you who never seen it, well, here it is. Right? And this is a pretty simple and somewhat useful model. Right? Looking at the GDP of a nation. Right? You have investment, government expenditure, personal consumption, and net trade. Okay, and now this model is useful for monetary policy, but not very useful for us, right? Because we don't care about any of these variables. All right, so we're gonna build our own, okay? And our model that we're going to use is going to be much simpler, much simpler. By the way, you are not required to know this, okay? Our model we're going to do very simpler, and it's going to be more robust because it's going to start from a fact that nobody can deny. So we're going to start with the basic fact, right, that GDP equals GDP. Okay? Nobody can argue with that. Right? And this is the essence of a good model. A good model is based off of very, very basic, simple assumptions, right? The more basic, the more simple the assumptions are, the less likely, right, people can challenge it, right? The less likely people can critique it. Right? And nobody can critique that. Right? I'm starting with a definition, right? Or sorry, I should say an identity, right? GDP equals GDP. Okay. So far, okay, but not very useful, right? Now remember, right, our goal is we want to learn something, right, about productivity and GDP. Okay, so how do I put that in there? Well, remember your math, right, that you can always multiply by 1. And I'm going to multiply by a 1 here, right, on this side, so it doesn't change the value, right? And the 1 that I'm going to use is population over population. Okay, all right, so that gives me GDP then can be expressed as, right, GDP times this. But now I'm going to do something a little, I'm going to do a little rearranging. So instead, I'm going to write it as population times GDP divided by population. All right, I just rearranged these things. Okay, now what does this get me? Well, now I can say that GDP is the product of population times GDP per capita. Because remember, like, this is GDP divided by population is just GDP per capita. GDP per capita. And what is GDP per capita? This represents productivity per person. Right? Okay. Now, next step, right, requires some calculus because I'm not there yet. I care about growth rate. Right? So I want to understand something about the rate. So not quite there yet. So next step, take some calculus. Okay. But before I do the calculus, I need to take the log because it is not easy and it doesn't help to take the derivative, right? To take the derivative of a product. Okay, now don't worry if you've never taken calculus, but this is one of the reasons why calculus is so useful because most of the times, right, we care about change in things. Okay, so I'm going to take the log. So I'm going to take the log of GDP, take the log of both sides, and then I get log of population, plus the log of GDP per capita. Okay, if you remember your algebra, if you take the log, you can write products as sums. Okay, product as sums. Okay, now I can take the derivative. So, and I'm going to spare you the derivative part. What we end up with is this: is the GDP growth rate equals the population growth rate plus, right? Plus the GDP per capita growth rate. Or let me just say per capita GDP growth rate. Okay? This is a fact that is somewhat intuitive, but hey, we derive this, right, with with an identity that we know is true from the beginning. Okay, and with some algebra movements, with some algebra skills that we also know to be true. So now we can more safely, right, rely on our hypothesis. Now, and one of the more important, now maybe facts might be kind of a strong word, but one of the more profound thing that comes up, after this exercise, is that what is population growth rate and its relationship to GDP, right? This is a direct, linear relationship, meaning the more population you have, right, the higher the GDP is growing, right? This gives us an idea or maybe a hypothesis, right? That hey, population growth rate might actually help your GDP, right? Not the other way around, right? The other hypothesis is saying that as population grows, right, GDP will fall, okay? Then in this model, right, the only way for GDP growth rate to decrease, then it must be that one of these decreases. Now, in Malthus' defense and Ehrlich and Thanos, right, maybe right, that there's a relationship between these two variables that this model is not capturing. Right? Maybe as population growth rate increases, the per capita GDP growth rate decreases. That might be true, right? And this model doesn't give us any more insight on that, right? But if that's true, then we could have a scenario where, as the population growth rate increases, this productivity actually decreases, and therefore the GDP growth rate also decreases, right? If this factor is higher than this factor, okay? Okay. Now we need some more data to see if that is indeed the case. Right. Now, okay, but if we break it down into these two, right? Well, what are some of the things, the factors that influence population, like population growth rate? Okay, and so what could increase population growth rate? Well, so for example, medicine. Right? Childhood mortality over the past 40 years has decreased dramatically. Right? Kids are not dying anymore. Right? People are becoming more healthier, right? And they contribute as part of the labor source. Right? Now, what about per capita GDP growth rate? Right? What are some of the things? Well, so technology. Right? With technology, each person can become more productive. Technology, education. Right? You're more educated, you're better at using capital, you're better at using technology. Right? That you yourself become more productive. Okay? But education, actually, education probably go here too. Okay, excuse my right handwriting. All right. What does education usually do to population growth rate? I should bring it down, actually. So, well, to a model, this doesn't really help, right? Okay. But maybe, right? All right. So education here, right? Education both bring down the population growth rate, but it increases per capita GDP growth rate. And if we observe that GDP is growing, right? At the same time, doing both of these phenomenon, then we can argue that this GDP, right, GDP growth rate, productivity, right, the factor is higher than population growth rate. Right? Education is making people more productive faster than it is decreasing the population growth. Okay. And that's basically it. There's not exactly. I mean, I think all of you could think of plenty of examples here. What I do want to focus on is these things: technology, education, right? Particularly technology, and I want to tell the story of how technology, right, help us avoid this limit to growth.